So we'll start with the inauguration session. So, good morning, everyone, and welcome to this course. It gives me immense pleasure to welcome you all to this intensive 40-hour online training program on mathematics of AI, algorithms, optimization, and beyond. So, this is organized especially for faculty members, doctoral scholars, UG and PG students, and professionals from academia and industry. So this program is organized and funded by Electronics and ICT Academy under the aegis of Ministry of Electronics and Information Technology, GUI. So in an era where artificial intelligence is no longer a futuristic concept but an everyday reality, it becomes increasingly important uh, to understand not just how AI works, but why it works. The mathematics behind AI, the algorithms, the optimization techniques, and the theoretical underpinnings forms the bedrock of all the intelligence systems we develop today. So this program is spread over 5 focus days from 26th to 30th May and is designed to bridge that very gap to take a deep dive into the mathematical and algorithmic foundations that power artificial intelligence. Through 5 comprehensive modules, we aim to equip participants with both theoretical insights and hands on experience. Let me briefly walk you through the modules that we will be covering during this 5-day short term course. Module 1 will lay the foundations of AI and classical machine learning, introducing participants to core concepts such as optimization, dimensionality reduction, and evaluation metrics with hands on exposure in basics of Python. Module 2 will explore optimization and feature compression, covering classical algorithms like decision trees, random forests, clustering, and regression, again reinforced through practical exercises. In Module 3, the focus shifts to the optimization of neural networks for classification and prediction, diving into logistic regression, support vector machines, and comparative optimization techniques. Module 4 will take us deeper into the mathematics for neural models, including nature inspired optimization, meta heuristic based deep networks, a blend of theory and practical implementation again in this module. Finally, Module 5 introduces the cutting edge topic of fractional neural networks and advanced optimization, touching upon mathematical concepts in image processing and optimization landscapes. So each session will not only focus on conceptual understanding, but will also offer hands on practice to ensure that our learning is both deep and applied. I would like to take a moment to extend my heartfelt thanks to Professor N.P. Padi, Director MNIT, who is also the chairman of EICT Academy, Professor Vineet Sahula, Chief Investigator of EICT Academy, Dr. Satyasai Nanda, the coordinator of EICT Academy, and the co-chief investigators, Professor Lav Bhargav, Professor Emmanuel Pillai, and Dr. Ravi Medina for their support in organizing this course. Next, I would like to extend my heartfelt gratitude to our esteemed instructors, organizers, and our enthusiastic participants. Your presence is a testimony to the growing need and interest in building solid foundational knowledge in the field of AI. I would like to take this opportunity to introduce the teaching assistants in this course, Ms. Rinki Sharma and Mr. Mukesh Delu, who will help us in conducting the hands-on sessions. We hope that by the end of this program, you will have not only learned new concepts, but will be inspired to explore this fascinating intersection of mathematics and artificial intelligence further. Thank you and best wishes for a productive and insightful week ahead. We will be starting with our first session uh, in 2 minutes, which will be taken by Professor Rajesh Kumar. We welcome you, sir. Rajesh sir has already joined us. And To the participants, if there are any queries, you can post your queries in the chat box. You can either post it to a specific individual or you can post it in general. And During the session also you can post the queries, or after the sessions you will be provided with all the materials through Canvas. I hope all of you have joined the Canvas portal link. The daily attendance will be monitored through this WebEx platform, and it will be uploaded in the Canvas portal. And at the end of this week, that is on Friday, we will be having a quiz based on all the lectures, sessions, and materials that you receive. Every day, materials, that is the PPTs and recordings, will be shared on the Canvas portal. 75% attendance is compulsory to gain a certificate for this course. And Apart from that, if there are any queries, you can post it on the chat box. Okay, so Rajesh sir, can you hear us?
Ma'am, good morning. How are you?
Good good morning, sir. How are you?
Yeah, I'm fine. I'm fine. Yeah.
So we are privileged to welcome Professor Rajesh Kumar, an eminent scholar in the field of artificial intelligence and intelligent systems. He presently holds the position of Professor of Artificial Intelligence in the Department of Human Anatomy and Physiology at the University of Johannesburg, South Africa, and is concurrently affiliated with the Department of Electrical Engineering at MNIT Jaipur. We are very thankful to have you, sir.
Thanks,
So,
ma'am, for inviting me for
thank you,
this
sir. Thank you.
FDP
So,
program.
thank you, sir. Before you start, I would just like to give a brief introduction of yours for the participants. So, Professor Kumar obtained his PhD in intelligence systems from MNIT Jaipur and has held a prestigious postdoctoral research fellowship at the National University of Singapore. He is also a distinguished lecturer of the IEEE Industry Applications Society. With a prolific academic record, he has authored over 600 peer reviewed research articles in reputed international journals and conferences and holds 16 patents. His interdisciplinary research spans across computational intelligence, artificial intelligence in healthcare, robotics, smart grid technologies, and bioinformatics. As the founder of the Raman Lab and Zine Robotic Innovative Club, Professor Kumar continues to foster innovation and interdisciplinary research across domains. Professor Kumar's contributions continue to advance the frontiers of intelligent systems and their applications across domain, and we are honored to have him share his expertise with us. In fact, I could not think anyone else but him to introduce and start this short-term course. Over to you, sir.
Yeah. Thank you, Dr. Priyanka, for such a nice introduction. Thank you very much. And let me share my screen and then just confirm that it's visible
Yes, sir. It is visible.
and my voice is also clear. right?
Yes, yes, it is clear.
Okay, thank you very much, and thanks a lot for such a wonderful introduction and such a wonderful beginning of a course. So, good morning to all the participants here in this very nicely designed course. I'm Professor Rajesh speaking from Johannesburg, so it's very early morning here and very cold outside, also 4-degree temperature. But I think we'll try to set a good platform so that we excite ourselves that why this course is very important and then how it will help us in understanding the things. Friends, AI is no more a branch or particularly confined to robotics and all that. Slowly now people understanding it. It's more like mathematics because you'll find everywhere now, and it's important for us to understand this new technology. If you look for the applications, I'll show you some of them. You'll find everywhere. And now when you move in depth of it, you'll say this is old mathematics, which is of era of 1950s and so on, and converted into a different framework or wrapped in computing, programming, and all that. So this course will give us, I think, more about the mathematics, what is there behind it, and then we can convert those things into some useful informations there. Okay, so starting with this one, I'll take few of the cases just to see that why this is important, and this is one of the picture I have taken it from an article of Professor Kundu. That is an image you can see on your screen, and this image says that there is no osteoarthritis in a person in the next 3 years. And then you take another image where this is saying that is osteoarthritis. And when you keep these two images with together each other, ah, you'll find it's difficult to identify which one is which one. And many a times you can just imagine the pressure on the doctors, the time they spend on you. Uh, there are chances of certain kind of error, but can we use or can we define or develop a technology which can give us better accuracy, better understanding of these things, so that it can help us as a user, help the doctors also to identify the things very fast. And here comes like your AI into it, or machine learning, which is a subset of it. Not only this, AI can see it in a different time scale. AI can see it what is going to happen, what is going to happen after some time, what is going to happen, or there are chances, and if there are chances, how long it will take to be there, or what is the confidence level, and it can do it in the time scale in both the sides. Like as on today, it can predict it what is going to happen, or we can go back that okay, what are those initial signatures if we capture it that time, or or which indicate that such kind of issues will be there. So this is one kind of a application which excites everybody, that okay, can we look into the future and can we find out more things there. There is one very another interesting example, and that is in the prediction side. Okay, this one is this Prof. Kosinski. He did a lot of work on the models, human models and all that, and then his team worked very hard. I'm just taking a very interesting case which you everybody should go and read about it. And then in 2012, he put kind of s- claims or kind of research arguments that if I have an 68 Facebook like, I can predict the skin color with a 95% accuracy. And think of, he's not checking your images so that he can tell you what is the skin color. The input is taking is the team is taking his likes, number of likes, but they can predict 95% accuracy. And then if you they can predict sexual orientation, predict which type of government you want, prefer democratic or republic, And not only this, they added so many things to it. They talk about that if I have only few likes, like around 70 likes or like, we can predict about your intelligence, your religious affiliations, drug usage, alcohol, cigarette, and all that. And then they increase it. They increase the things there, that if the data are more, they can talk about other things also involved in it. So they improvise the models. They improvised models with a very high accuracy because more data they have. Like if we increase the data 70% likes, we can talk about person's friends. If we have 150 likes, we can talk about what their parent knew. If you have more likes, then what their partner knew, and likewise. This is something very interesting, and because of that work, then Facebook has to do certain modifications in data privacy and all those things. But the point is, uh, we are looking something else, and then we are predicting something which is different, and that is basically the main power here. So we are using certain kind of mathematical operations, some kind of a relations between the connecting points, and then try to find out what is there, what is going to happen in that. And that is basically a kind of a thing which excite people to talk about the artificial intelligence. And the definition is very simple: intelligence exhibited by machines. So what is the intelligence exhibited by machine? Because we know that intelligence is basically ability to learn from the environments, interaction with the environments. But can we make our machines in that way? And then this era developed us in a big way. So what is the evolution of AI? Initially, the reactive machines came into picture, where we don't have that much of big memories. They react with the current situation, what is happening there, and based upon the environment and the current situation, they take the actions there. Some example is like, okay, playing a chess. So uh, playing a chess, but not considering that memory, that one. Okay, what is the current scenario? What move I'm going to take it? Then there comes in like AI with limited memory. So we have certain memory, we have record of certain data, and then from past data they are used, and there is the record is being used to develop a certain kind of a representation of the environment or to take certain actions. And self-driving vehicle is one example of this. So now you can think of where we are right now here only. Then what is the future then? And the future is basically the everybody is working towards the theory of mind, that how mind will work. And then when we talk about the theory of the mind, it is basically a representation about the world, how world can be represented, how agent can learn from the understand the environment and take actions. So that is the theory of mind, and this is the ultimate goal, that is self-awareness. Can we make our algorithms or machines self-aware, aware of emotions, aware of reactions, and likewise. So during this lecture, we can talk. We will talk about AI. So AI and machine learning. I'll keep on swapping these words, but to be very clear, machine learning is a subset of it. Don't get confused. That what is there. So we will talk about how it works, what are the various sections of it, what are the applications, and this opportunity in this domain. So this will be the flow of the lecture today. And this is one interesting slide I have taken just to talk about, just to think like, okay, how human learn. So okay, I have a situation here, and the situation is simple, that okay, there are chilies, and then should I eat or not? That is the question there. So I have certain thing is the scenario there, and then I have to make a decision. Should I eat it or not? Okay, now the situation supported by one information, that there is somebody who tell me that no, this is just check it. This is red chili, and be very careful. It's really hot. So somebody is there to give me that information. At the same time, okay, I have something that okay, last time it was not that hot. I mean, I eat it a month before, it was not that hot. Well, these things you'll find common every day-to-day life when you're handling such scenarios, and we call it the data which the second person is sending to me, because that is information is shared to me that these are rare chilies, these may be hot, so be very careful. And the another one is my past experience, that last time it was hot or not. We use these two things and to develop certain models, and you'll find everybody, everywhere you'll find that these two are used in a different form there. We use data and we use past experiment to make our decisions. So that is a way we do it at a human, and then we learn from that. We take certain actions and then we learn and then we modify our experiences, and then we modify our perception about the things. And the same we want to be to be done by the machines also. So we'll find a lot of data across everywhere now, and that is why you can see this domain is becoming very popular. So we want our machines to learn from the data. We want to improvise our performance, and we want to predict without programming. So this word is confusing, that okay, why, how you can in machine learning or AI also we do programming, but this is something, the difference is there. We'll see how it is. But this picture is very important. Okay, taken from Google. And many time people get confused. So AI is a big picture. You can see AI is a big domain where we talk about intelligent systems. Okay, and then machine learning, it's a subset of it. So so we are trying to learn without explicitly programming it, and then deep learning is a subset of next level. So that is more towards deep neural networks. So don't get confused that, okay, many times people say deep learning and AI. AI has many subsets. Like AI is one subset is what we are talking about right now. Another is fuzzy systems. Another one is knowledge-based system, and there are many like that one. So this is the structuring of this part there. So in machine learning, what we will do, and let me check it if it is there. This is a major difference. This slide is important. What we do, what is difference from the programming. So in traditional programming, we give a data, we give a program, and the computer give an output. And in machine learning, we give data and the output, and we ask computer to program it. Let's make it simple. Okay, so I have x is equal to 2, and I know the relation of y is equal to 2x. So I write a program that, okay, input x is equal to 2, y is equal to 2x, run the program, and it will give me y as a 4. That is a traditional programming. In machine learning, we do it other way around. What we do is we give an input to my machine learning method that x is equal to 2 and y is equal to 4. Give me a relation between y and x. So it will do, and it will give you certain kind of a model there, depending upon the relations and all this. And that is a major difference between the two approaches. So both are using oh, at the surface level, both are using some kind of a mathematical programming or computational programming, but the approach you can think of, it's a different. One give us a model, another we pass the model, and it will generate an output there. And why we use it, I told you, because since we are using a lot of now IoT devices, lot of other sensors and all those things, so we are having a lot of data. We are recording the things, and those things should we can analyze it and analyze. If we try to analyze these things manually, it's difficult because of three V's there. So there's a lot of the volume of the data is very high. You can see now the data there. Earlier data we talk about MBs, then GBs, now then TBs, and So the data amount is very high, and there is a variability in the data. So data can be, if I take only about say healthcare, so we will get a data which are in numeric terms. We will get a data in terms of signals. We will get a data in terms of the images, and all belong to same person. So there is a lot of variety in the data, and then the data transmission and the velocity and all those things are also different. Okay, so so if such kind of scenario is there, then it's difficult to do it manually, and we need certain kind of methodologies to solve these complex problems. But there are patterns which are hidden in this one. You'll find nowadays people are talking about something. Some always you'll find you'll see the news around. People are measuring or finding the things inside the body without going inside the body. People are finding the even they are accurately predicting the various structures, various things without having knowledge of it. So predicting the temperature without having the knowledge that what is the phenomenon which is physical or phenomenon which is occurring there. They are just taking some past data and develop some prediction models and try to predict it what is going to happen, and likewise. So there are certain patterns, and these patterns help us in finding the outcomes. Let's talk about what are the different legs. So you can put it like legs of ML because I'm taking subset of it. I can see the most of the course contents we are targeting that way. If I talk about the legs of AI, we have to add more to it because ML is a part of it. So AI, if I talk about it, starts with, you can put it one leg of AI as a knowledge-based system, KBS, we put it. The another leg of uh, uh, AI is you can put it fuzzy logic system. Third one, you can put your machine learning algorithms. Fourth, you can put is thinking machines, thought machines, and there are various such kind of arrangements there. But these are the something very popular and people understand through this one. So there are three categories we can put it. One is supervised learning. The another one is unsupervised. These are known as classical learning methods. And then there's another leg which is known as reinforcement learning. Okay, so what is there in supervised? Uh, in supervised, the name suggests that means there is a supervisor who tells you whether what you are doing is correct or it's not correct, or you have to improvise it. So if there is a supervisor sitting there and telling you the correctness of your finding, then algorithm is known as supervised. So so then if we put it like that, that okay, this is way, then the question is how my computer program will consider it. So there must be something in computer program what I'm writing it that tells me that okay, what why my model is predicting that is not correct. So that means what? That means my data I'm passing it. My data are labeled data. That means they are labeled in a way that for that X input, we know what is the Y actual value. So if my data are labeled and I develop a model around that one, we are moving towards a supervised learning. There is another approach, unsupervised. Unsupervised means there's no supervisor. There's nobody to tell you. That means your data are not labeled. You have data, but they are not labeled. And then we try to do some operations over it, just to find it out that how we can find a similarity between them. Can we make some kind of a grouping of all those things? And can we find out after grouping, we take only few samples, and based upon that we can label them, and there are many other applications. And the third one is reinforcement learning. This is interesting in a way, like we learn with time. So what in reinforcement learning, what is you can take it like this, that we perform certain actions in an environment, and when we perform certain actions in an environment returns back something to us. Either it will give us a reward, or it will give us like positive reward or it will give us a negative reward. And based upon the reward, we modify our actions. And our goal is always to collect maximum rewards. And by that process, we learn. And that comes under this category that is known as a reinforcement learning. Okay, let's divide it further. What can be done there? So supervised learning is basically we usually perform two operations. In most of the algorithms, we usually go for two operations. Uh, that is regression or classification. Okay, so in one case, we are looking for a new value. So if I am looking for a new value, that comes under the category of the regression. That okay, given certain values, I have certain outputs. But if I give a new value, then what is the new value? Just very simple example. Okay, given a set of heights, and then and then I'll take a new sample and then I'll ask, okay, what is the height of a person? So I'm looking for a value there. That's a regression. But on the other side, if I divide these heights in a tall and small, and then I pass a new height and ask what is whether it's a tall category or small category. So if I'm categorizing it, that comes under the category of the classification. So that is what we we do here. And discriminative. So most of the models are generative and discriminative. Generative models where we generate a value, and discriminative models where we discriminate it, we classify the things. In unsupervised, we do three things, like we cluster the things, cluster on the basis of the similarity that they belong to one group and likewise, or we look for dimensionality reductions, because when I take a data, say a person about a person, so a person, we can put so many things like, okay, it's a male or female, or the person is wearing glasses, not glasses, it's undergrad or masters or PhD, it's hostler or day scholar, many things. And then okay, if I have even ID also, so I put ID number. So now there are these all these are the features, or can we reduce it? So we always look for a minimum number of features which solve our purpose, because that will reduce the complexity of my algorithms, and it save my space and all that. And we also look for associations between the data and all these things. So if we follow all these things, that comes under this category of unsupervised. Well, then with the advancement or with more things, we can subdivide it. So classical, I put it all together. Classical means supervised and unsupervised, but then two more legs there. One is ensemble methods, and the another one is neural network and deep learning. So you will find later on during the course, you'll find neural network, you can correlate it from the supervised approach and then going for a nonlinear functions to it. And then you'll find people put a lot of work to prove it, that how it is similar, how much similar it is with the human neural systems and all that. And then people increase the size of it and they move towards a deep neural networks and deep learning methods. Ensemble methods are basically derived from a concept that uh, we start with a very simple machine learning algorithms like decision tree, which are very simple in model, but they fail to perform better when the things are complex, when my data are complex. So then the theory is, if we combine the weak learners, we call these models which are light models, they are weak learners, but they have advantage. So now later on, when you move into depth of this whole domain, you'll find there are another thing which is coming up, which is known as explainable AI. So can my AI explain why my results are like that? So these models, which are simple models, they are good in a way that they can explain the things in better way, but they fail when the data are more complex. So the theory in ensemble methods is, can we combine weak learners to develop a one strong learner? And then how you combine them, whether you are combining whether you are combining in a sequence, or whether you combine in parallelly, or whether you combine them in a stacks, or any combination of that. So whole that category comes under this kind of classification. Those are known as ensemble models. And now these are the certain methods. These are the mathematical models, which most few of them you are going to study in this course. So if I talk about the classical methods, we will talk about decision trees, support vector machines, linear and polynomial regressions, naive Bayes, KNN, and all these things. So these are basically simple mathematical arrangements which we will try to we use for to develop certain models. So few of them are deterministic models, few of them are probabilistic models, and then we use it. In deep learning, you'll find the another level of it, which is basically RNN, CNN, encoders, and all these models. Ensembles are basically of three types usually: bagging, boosting, and stacking. So in one case, we connect them in a sequence. In another case, we put them in a post parallelly, and in the third case, stacking, we put in the stacks. Again, reinforcement learning, again, we have different models. So we have SARSA model, which is state action, reward state action. That means we we are in a state, we take an action, we get a reward, we reach to a new state, and then we perform next action. That is SARSA. And then there is a Q learning, deep Q learning, and GA, and you'll find now a lot of other models are also there. I'm just putting the basic models which are here. Well, if you are working in this domain, you must have these are the few softwares which you can use. They will help you a lot. People are using in a very big way. Most of this one which are there on your screen, these are Python based models. So you can use PyTorch, TensorFlow, Keras, Apache, and all these things. Uh, there are certain advantages. Python is open source and people have already developed these libraries. So suggestion is two-way. One, you must know and understand the mathematics behind these models. And the second one is, then if you are okay with these things, you can directly use these libraries without wasting your time. But if you want to develop your own libraries, you are always welcome. So these are the few softwares which are available, which are good for all ML users and all that. And the way, this is a common question which everybody asks, that what is a good way if I'm a beginner, I want to start machine learning and AI, what to how to start it. And these things are there which only everybody uh, here in this course know and gone through these things, but my suggestion is just revise it. First, linear algebra, probability, calculus, stats, univariate and multivariate, and information theory. So, and these things we don't need very high level learning there to start with. Even the school, high school level learning is okay to start with these models. Later on, depending upon how complex and how advanced algorithms you want to develop, then you can develop these skills there. So the approach is bottom up approach. You start with these things and then you develop it rather than going from top to down. And this is the way. So uh, way to develop a good model. And if you don't follow, then many times what will happen, that problem is there, you know, the algo methodologies, you know, the methods, but then there are so many methods. If you just check on it now, the you can find more than thousand of methods which to use, and then you start using with the wrong one and you waste a lot of time. So what is the way is draw your schematics so that you can understand how to process it, and then understand your data set, because that is very important. What type of data? See, my data set is very simple. I share you one of my our experience. We were working on certain problem of electrical engineering, try to develop some tool to predict certain kind of event in the electrical system. And then we initially thought of like, okay, this is complex, so let's try with some higher order models and all that. So obviously the accuracy increases, but we found that okay, it's difficult to put it in the real time frame. And then we come back to the very small models, very light models, and we found that, okay, we can, even if we compromise on the accuracy of 0.5%, it's good because these light models are very fast and very easy to build on the hardware. So that is that what I mean here is that waste your time. So understand your data when you are going to work on it, plot it, check it, how complex it is. Sometimes if you just see it from a different angle, you find, oh, this data is linearly separable, and I'm trying with a deep neural network or something like that. So understand your data, map the tools for it, and before that, prepare your pipeline that how I'm going to process on those things. And we talk about the applications are endless. You can find a lot and lot of applications. Okay. So if you check near around, you'll find that we have applications in science, physics, chemistry, bio, full of it. Agriculture, you can think of predictions, crop disease, greenhouse. Lot of new applications are coming up. Finance, medicine, bioinformatics, security, defense, crime management, image processing, robotics, automation, traffic prediction, product suggestion, language translations, entertainment, self-driving vehicles, weather predictions, and all engineering with scheduling, epidemiology, disaster management. So now you'll see that this whole filling a map is now becoming overcrowded because you can just you now you cannot think any domain without this AI and AI applications. You can find you'll find there are possibilities of using AI and making it more automated and better solution providing technology. Okay, so this one is again the same thing, but I added few more things here. So just to put it, the application side. So like classification, most of the classification is on the medical diagnosis, because in medical diagnosis we always look for yes and no conditions, and then same is this in the security and crime management. Crime is there or not there or something like that. Uh, Image classification. So it itself explains you that okay, we are talking about the classification. Customer retention, whether the customer remain there or it will leave. So it's a yes or new kind of a situation. Integration, some examples like we are forecasting. So we are trying to find out a new value. So right now the temperature is 5 here. What will be the temperature after half an hour? Or what will be the temperature after 1 hour? Or predicting the wind or and stock prices and many more things there. So we have predictions, we go for forecasting, we go for the optimization process, or we are looking for inside the new patterns and all that. In reinforcement learning, it's like self-acquisition, robotic navigation, learning task, real-time decision, and the most best example is your chat GPT. So it learns and answer in the real environment, and then again it will learn and getting better with the time, and it give you real-time informations and all that. And then when we talk about unsupervised clustering, we make a like targeted marketing. So those who are moving in that direction, it is there because okay, these are the data, and I want to design my marketing for an age group of 18 to 30. So then 18 to 30, I'll take the features, make groups and clusters, and then check it out. What are the likings, dislikings, or the purchasing power, and likewise, and then I can go for marketing plan for that. Similarly, the recommender system. This is nowadays very common. If you go to any online shopping system or something like that, you search one thing like, okay, you search laptop, but at next you to it, you'll find that those who have purchased this, they have also purchased this thing, this thing, this thing. All these are the recommender systems there. Or even if you are working or you are watching online uh, OTTs and all these things, you will find that okay, your page is designed it will appear in that way that what are your likings accordingly. Your these uh providers, they open a page for you. Similarly, if we are looking for dimension reductions, so we have big data, and then how we can compress it, how can we'll get a good features out of it, that comes into the category feature selection. Can we discover the structures? So that those comes under those categories. Associations, we look for interconnection between the things there. So some examples which are already being implemented, I just share with you. You can think of extension of this one, and this one is the first area is healthcare. Okay, so quickly I'll just put these things so that this will give you a certain kind where the technology is already being proven. So we have now record of health data. We are wearing a lot of devices now, and these devices give us a certain kind of information, maybe through your wearable technologies, bands and watches and some other kind of sensors there. And that is basically you can make it a record, a digitized record, and from there then you can find out the patterns. So patterns are there, and then we can find out the specific disease and rare cases and all that. So these are the areas in healthcare where people have already implemented this technology, and now they are coming with everyday new things there, like automated image diagnosis. So nowadays, you have certain examples, but people are not thinking that way. Like X-ray, you go to for X-ray, and then you can see the report is generated after X-ray. Even the doctor signature is also a digital signature, unless until there is something very critical. It is mostly that AI tool, they generate the report, and then okay, it may be verified by the doctor there. So it's a kind of arrangement there. And now this one is getting a bigger one. You can see a lot of articles, videos, and everything where in certain challenges, machines they beat the humans also. So that is one area. Then preliminary diagnosis. Can we catch the things very early? So can we go for preventive kind of or early detection kind of arrangement so that we can save the life? Workflow will be fast, because this one is another area where the people are using AI approach to make the workflow smoother and optimal. Cybersecurity is always a challenge in healthcare. Reason being that if these data they leak and then and share to wrong people, then it will affect in many other zone, like talking about the medicines, pharma industry, insurance companies, and individuals also. So how to keep these data very secure and all that. And remote consultation, we have seen one kind of arrangement during the COVID that we use a mobile app to talk to the doctor. But now we are talking about healthcare, which is supported by AI. And I think, if I'm not wrong, it's just 1 week before in Dubai, there is a new totally AI-based hospital where the AI doctors I'm talking about, they can treat up, I think, around 40 diseases or something like that. So this area is building in a big way. Robotic surgery is now at most of the places there, and we have already discussed on the remote consultation. We have seen this scenario. We have seen this thing scenario in epidemiology. So it's a lot of models people have developed. Many have used data. Most of them they have taken data driven. So when they develop these models, they are purely data driven models. Some used mathematical operations to drive those relations, and then try to find out various kind of scenarios that okay, how the disease is spreading, how it is being controlled, and all these things we have already seen last during COVID period, that how the spread is there, how many people and how it is spreading, and various models people have developed. So it's not like only the AI based, but few people have developed other mathematical models also, but many of them try to develop it from the perspective of okay, taking the data and only on the basis of the data, then try to find it out what's going to happen. So this area, this domain is still open, and people are working with the more working towards some more accurate models and all that. Okay, in traffic you will find a lot. now a lot is there in a way that most of the smart cities they have implemented when many of such kind of devices there which predict the traffic and then automate the timing of the red lights and green lights at the crossings. It helps in traffic management that way. Identifying the violators, you increase the speed, violate the speed, change the zone at a wrong speed, it automatically detect it and then send you a message on your phone. And in some advanced countries like Singapore and all that, the money is automatically detected from your account also. So such kind of scenarios, people are already there. Identification of vehicle numbers, stolen vehicles, and all these things. So these are few examples like where now it is tested technology and it is in use. Smart grid, those who are from electrical engineering, they are using talking about this, where we predict the load, we predict the resources, we predict the consumer behavior. That is now very important in electrical engineering. Earlier, people uh, they never talked about like okay how the consumer is consuming the electricity. They talked about okay this is the load, this is the supply, how to meet it. But now they are working toward okay how the what is the behavior of a consumer, and based upon that what will going to happen after 2 hours or something like that. They are using it on the demand side management as well as on the generation side management. Defense is full of it. So we have seen few scenarios, past few. Now the attack is very precise. So they use it for target recognition. They use in warfare platforms, image processing, health crisis healthcare where defense supported, and then threat monitoring activities, cyber security. So lot of applications you'll find in defense and the merger of this technology to those that domain make it more and more intelligent and very precise one. We started with agriculture, and these are the few areas where we can say that okay, it is being implemented like to identify the species. Greenhouse, I told you, crop disease, what is the disease, what how the treatment is being done, farm management decisions, estimating the yield, and if something happened in particular zone, how to estimate the amount of the loss and all that. So the so that agriculture is now becoming intelligent. New zones are also opening up. Okay, taking the sample of soil, auto estimating its components, and then connecting with the growth of particular kind of a crop, and then the requirement. Okay, what are the requirements there? And then optimally utilizing those things to increase the yield and and likewise. So we have a lot of applications in agriculture. Now this one is a domain, few things which is now I would like to put it here. Reinforcement learning. This is becoming a very popular. It is being used, but it became very popular after if I say large language models and then people attracted in a very big manner when we talk about okay we are working with all chat GPT models and all that. So reinforcement learning is basically you can it has a lot of application not only in this domain but in robotics and control and automation also. And you can see that what is how it works. So robo is there and it has to take a decision. It has to go towards the bucket, but initially say it moves in the wrong direction. The sensors give idea that no, it's a fire, high temperature, so it will give a penalty. And penalty means it's not good. And next time it will not go to in that direction, it will change the direction. So you are making a machine intelligent. We call it these as agents. So you're making the agent intelligent, and agent will become agent by self-learning. So that is a part here. Large scale machines are now coming in a big way because of the revolution in the electronics. So you can see the type of the data, and then now these machines are humans are in the pipeline. So we are talking about human interaction, machines, and all those things there. This is in a very quick mode. This is about a deep learning. So you can see here what the deep learning models. Just let me take a look. So initially, this one is a simple neural network which uh, came in like 1980, where okay, we pass certain features and then model is there, it gives certain output. So what are the features like, okay, I want to recognize from the face, male or female. So face, I'll take, okay, shape of the face, and then hair, and then eyes, and then lips and nose, and likewise. So those are my features, and based upon that it will give me output whether male or female, something like that. So but now the this model which if I use it, it totally depends upon what I'm giving it the input there. Then people come out with this with the idea that, okay, why should I give it? Can I develop a model which itself extract it? So what they did it, they make it deep. You can see it's bigger one. So they increase the length of it. And now they pass the image and let the model to learn the features of it so that it can identify. And this is basically make it more intelligent, and that's the beginning of your deep learning neural network, and lot of different models are coming in that way. And then people come out with another kind of, that is convolutional neural network, because when they put it, so the next generation or next level always depends upon what are the challenges in earlier one. So what is the issue with this one is basically when you put the image just same like this, then the results are good. But if you rotate it or transform it a bit, and if you want to find it out, it has certain issues. Accuracy is not. So then they come up with the convolution process, use some more mathematical operations, and then another level or series of convolution come into the picture. And all these models are deep in a way because the length, you can see the length and the connections between these points, they are very large, and that's why these are deep learning models. Computer vision applications, we can see a lot, and most of the computer applications you'll find AI. So a few of them, they are surveillance, 3D object recognition, games, reconstruction, navigation, robotics, inspection, human computer interface, segmentation, and many more are there. Natural language processing, you'll find a lot, and now these things are around you. Okay, you can convert text to voice, voice to text, text to image, voice to image, image to text, and all kind of a combinations. So now this domain is building it up very fast, but at the lower level, you'll find all the things are, it's basically first you convert it into data, and then they process it, apply some techniques, and then convert it into back into the way you want to use it. Some applications like plagiarism checkers, document summarizations, spam filters, machine translations, these are already there. Translation is already on your, even as on today on your smartphones. You speak in English, it will give you in Hindi or Japanese or Chinese, or you speak it, it will convert into text and likewise. So this domain is there, which is there. Internet of Things, it's a huge. You can see wherever is internet, you can think of all this data, you can think of all how these data can be used most optimized. So IoT I is you can see the applications: building, energy, consumers, healthcare, industry, transport, security, and there are then subsections and then subsections, and further it is becoming day by day, it's becoming very big and very wide there. Going further, this is important. This slide in a is important in a way just to give an idea or a domain which is becoming it is popular since its birth, but now people are talking at a different platform or scenario there. So if I go by this pipeline, you can see it's not new. It started somewhere in 1940, and whereas 40 is a break line, but the learning, you can see it started in 1928, and the popular it will become when have come to came into picture. So Hebb's learning is very popular, which was coined in 1949. He was a mathematician, doctor, and philosopher. So he proposed it. So that was a breakthrough. And then 60s we have breakthrough on the neuron representation. So those who work on this direction, learning kind direction, they follow this line. But at the same time, then the neuroscience and psychology, they come together and they move towards data-driven approaches. So one leg out of it, it comes as a artificial neural network. So ANN initially started with MCP model in 1943, then perceptron comes in 58, and then 75 we have cognition in the Hopfield 1982, and then then there are two lines. One of them they use this Hopfield and approaches, and then deep learning with Hinton in 2006. The second line comes with the statistical machines when we talk about decision trees, 1966, and then SVM and then random forest. And the third line which comes here is basically dynamic machines, where we talk about reinforcement and Markov models and uh, MDPs and then advanced reinforcement. So all these things, these three legs, they came from neuroscience and physiology, and now they are becoming, all the three zones are very popular. Industry people, usually most of the industry, they have their data are of a simple in nature. They go by the statistical machine. uh Imaging and high level decision making, they go for ANN, artificial neural network, using deep learning and all those things. And then where the environment is dynamic and we are looking for dynamic machine learning, like NLPs and LLM models and robotics and all this. And so they usually, you'll find a lot of applications. They are using this dynamic machine learning approaches there. So okay, so people have already tested it. This I think we have discussed. Application parts, it's just a repetition. Okay, so no, okay, we are towards the end of it. We have done a lot of work, but yeah, since we are short of time, so I'm not explaining what are the where we have implemented it or tested it and developed the technology. But if you are interested in, then you can if you are at MNIT, you visit our team from mathematics and engineering. If you want to see the products which we have developed, you can go to Raman Lab. You can see the things there, or you can visit the website of Raman Lab. There are a lot of detail about the products. If you are curious, you can write to us. So I keep last 4 5 minutes for the questions. So I stop it here, and now I'm open for the questions. So if you have any questions, type in the chat box, or what you can do is you can unmute yourself if you are allowed. You can ask the questions. So I'm open for the questions. If you have any, please put it here. I'm happy to discuss those things with you. Any questions, please? If you have any questions,
We
please
have
share it.
a question in the chat box. So if you can see the
Okay, so a question is, okay, let me take the questions. Let just one sec, give me a second. Okay, so question is, okay, the how ChatGPT works and how to use RL. So okay, RL is a complete domain in a way that how it works. You need to understand RL. RL is we are in. There are three things in RL. If just in a simplest way, I can put it for you. One is the state, and the state is basically what is the current scenario in the environment where I'm putting it. And the second one is looking that scenario, I'll take certain action. Uh, like you ask a question to chat GPT that give me this thing. So looking to your question, chat GPT provide you certain kind of a answer. How it comes, that is a second theory, but let's understand how it works. And then at the bottom you will find that there is a thumb up and thumb down. It asks you, okay, are you satisfied? Then you put thumb up. So thumb up means it's a reward which goes back to the chat GPT system, where that okay, this is the user is happy with it. And if you put thumb down, that means user is not happy, and then it will try it again. But at the same time, what it will do is it will save that information, and it use that information to to update or modify the knowledge. So that is how it will learn with time. So so you are a feedback mechanism, because you are providing a reward to it, and the whole process in RL is playing between these reward and actions, and the ultimate goal is how to collect maximum rewards. So that is that is how RL works. And ChatGPT is basically, these are the language models. So when you move into it, it's not as simple. Then if you, in a way, like it's purely RL. Its other part is that they are using attention models, they are using sequential models and other models also. When they convert it from text to some other forms, or from text to what the next text, and likewise. So there are two, three different zones which are mixed here in ChatGPT, and that is the way they put to you certain kind of solutions, and that's why they're becoming intelligent. So ChatGPT 4 is much intelligent than the ChatGPT 1. I hope I'm able to answer your thing in a very compressed manner, but this domain is very interesting and full of many things. Nowadays, people are using, they have modified the new models. You pass the image to to the model, and it will generate everything about it in a text format. It identify the landscapes of the image, it identify the distance between the landscapes, and not only that, if it's a medical image, then it can give you certain kind of a recommendation that what is going to happen there. So now the technology is growing in a big way. Any more question? Okay, so you can okay. So MLDL recommender system needs good data, but quality data is hard to get. What can be done? And yeah, this is always a challenge, Mr. Chandrasekhar, that to get a good data. But if you follow the new approaches and where people are working it, that is how to develop a good model with less number of data. Okay, so there are various ways. Okay, one of the challenge, I think, yeah, Mukesh is already there. He's also facing that his sort of data, and then how to get the data, how to solve the model. But there are approaches people are using. One approach is they are using other models like generative AI models to generate the data. That is one way of doing. Second, they are using certain kind of operations that certain kind of operations that they rotate the image, translate the image, in, add noise to it. So they are generating it synthetically. So artificially they are generating it. That is another way of doing it. And the third way is, can we develop an more? Can we develop, or can we apply uh, our new mathematical operations, just so that can we extract the things in a very early stage with less number of the informations. So those things are still on, and people are working for it. But yes, right now, right so one approach is this RL, what I'm putting it, because RL, it doesn't need a lot of data. It will start with the less data, and then based upon the response, it keep on modifying itself. And now people are mixing this one RL with other models, so that can we answer this challenge in other models where we need a lot of data. Can we develop those models with less number of data? I hope you are able to answer. But the next question is, the resources are needed to, what type of resources are needed to work on neuromorphic computing? Resources is okay. You only thing is, okay, you need a certain data, you must have a challenge, and then okay, you must have knowledge of mathematics, then how you are going to use it. And and then how you, what concept you are taking it further. Like one another approach which people are now working on is that can we make a neural network as close as the human biological neural network, and that's why they are moving from a conventional neural network and the another domain